Okay, welcome to Mastermind. This is our final questions for probability. Now, at Mastermind, we dream, we believe, and we achieve excellence. So now, we move on. We have our final questions that we have to tackle. So these are the final questions. Question number 1. A box contains 3 white, 2 blue, and another box contains 4 green, 5 blue balls. If a ball is picked at random from the box, find the probability that A, one is green and the other is white. B, they are of the same color. So with this question, we have box A that contains 3 white, 2 blue, which compromises of a total of 5. And we have box B that is 4 green, 5 blue, which compromises a total of 9. If that is the case, we pick one ball from each of the boxes at random. And we are asked to find probability that one is green and the other is white. So let's just choose a green ball, and the place we can choose a green ball is the box B that contains a green ball. And because box B contains a green ball of 4, so 4 out of 9 will be the total number of green balls, the probability of picking up a green ball. So we have green from box B and the white from box A. We can only get a white ball from box A. You can see there are no white balls in box B, so you can only get white ball in box A, and that one we actually get that. So green box from box B and white ball from box A. Probabilities are written. So he said one is green, and did you see "and" over there? The "and" really mean multiplication law. All right, multiplication law, right? Okay, and it's independent, right? Okay, so we have, since both events are independent, one pick from each box is going to be this times this, and we are going to get 12 all over 45, which finally cancels out to become 4 out of 15. So 12 over 45 now cancels out to become 4 over 15. Now let's move on. Probability that they are of the same color. So we look for same color combination possible between the 2 boxes. We are going to look for the same color combinations possible for the 2 boxes because they are the same color, right? So blue and blue, or we have blue and blue, and the only blue and blue we can have here is picking a blue from box A and picking a blue from box B, right? That's the same color we can choose from the 2 particular events from different boxes, right? We are not choosing from the same box, mind you, different boxes. So we choose one blue from each box. Blue from box A. So blue from box A becomes 2 out of 5. And then blue from box B to become 5 out of 9. And then we have final answer become 2 out of 5 multiplied by 5 out of 9, which become 2 over 9, because the 5 cancels out. The 5 actually cancels out to get 2 over 9. Now, question 2. The probability that an event A occurs is 1 out of 5. And the probability that an event B occurs is 1 out of 3. Assuming that the 2 events are independent events, find the probability that A and B both occur. Neither event occur. At least one of the events occur. So the solution, we have probability of A 1 out of 5, probability of B 1 out of 3. If both A and B occur, we are going to have our independent formula for multiplication, and that will be probability of A and B both occurring to be this, and then 1 out of 5 times 1 out of 3, and that gives us 1 out of 15. So now probability that neither A nor B occurs, so none of them is going to occur. So if none of them is going to occur, it's 1 minus all of them, or A and B occur. Probability that neither A nor B occurs. Yeah, so probability that A will not occur, none of them should occur. So let's solve individually the cases where each won't occur. So 1 minus 1 out of 5. 1 out of 5 represents A occurring. So A not occurring is 4 over 5. Then we find B. You see that 1 minus B not occur, B occur will give us 1 minus B not occurring. And that gives us, since A and B are independent, their complements are also independent, right? Then we have probability of A not occurring and probability of B not occurring, 4 out of 5 times 2 out of 3, and we have 8 out of 15. Probability that at least one of the events occurs. Remember, what does at least one of these events mean? It means either A happens or B happens or both happen. It's also called the union of A and B, written as that. Now, at least means greater than or equal to. So it should be more than or equal to what we are calling for. At least one of them. So at least one of them means both of them can occur. So we have P of A plus P of B minus probability of A intersection B, where they actually occur together. Because it's addition, or did you hear at least one of them occurs? So we have 1 out of 5 plus 1 out of 3 minus 1 out of 15. That gives us 7 out of 15. Then we are done. Let's move on to question 3. The probability that Kofi goes to school on a market day is 1 out of 5, and the probability that his brother also attends school the same day is 3 out of 4. What is the probability that both were present? At least one was present. Exactly one of them was present. So probability of Kofi going to school 1 out of 5, of his brother going to school is 3 out of 4. So we assume the events are independent unless stated otherwise. So you have independent event, they can happen on the same day. So we find the complement of the probabilities because we are asked to find both were absent. So we are going to find complement of each. So probability that Kofi is absent is 1 minus 1 out of 5. We have 4 out of 5. And probability that his brother is also absent is also 1 minus 3 out of 4, which is equal to 1 out of 4. So having that, we can actually have probability that both were absent. We are going to multiply their complement of being present. 4 out of 5 times 1 out of 5, and that gives us 1 out of 5. Now you go on probability that at least one was present. Probability that at least one was present is going to be at least one present. It's a complement of both were present, because at least one is present. At least one is present. Take note of that particular concept. At least one present is a complement of both were absent. So at least one is present equals to 1 minus both were absent. And we have 1 minus 1 out of 5, because we saw for that in the earlier question. We have 4 out of 5. Or we can decide to also use Kofi goes to school 1 out of 5. And his brother also goes. So we are looking for at least one. So it means that it's either both of them or one of them, right? So since we are not told otherwise, we assume independence, and we find a probability that both of them will go. That is 3 out of 30, right? And we use addition law when we want to find the probability that at least one of them, one of two or more events occurs. To find the probability that event A or event B occurs, it denotes P bracket open, Kofi union B, or Kofi union his brother, or K union B, right? Then we subtract both occurring from that, and we have 4 out of 20 plus 15 out of 20 minus 3 out of 20, and that gives us 16 out of 20. We cancel that out to be 4 out of 5. You see, we have the same thing over there. Exactly. So when you have questions like at least one of them occur, it's either you solve using 1 minus both of them were absent, or both of them will not occur, or you decide to find circumstances where both of them occur, subtracting or minus individual occur minus both of them occur in that order and regard. Rewatch the video over and over and get the perfect understanding for this. Probability that exactly one of them are present. This happened in two cases. Exactly one of them is present. That means that if one is present, the other will be absent in that case. So if Kofi is present, his brother is absent. If Kofi is absent, his brother is present. So we deal with it like that, and we look at all the possible chances that there will be in that case, and then we can add their resultant and get 13/20 to be final answer. All right, let's check out question 4. A box contains 5 white balls, 2 black balls, and 3 red balls of the same size. A ball is selected at random from the box and then replaced. A second ball is then selected. So we pick up a ball, you place it, and you select a second ball. Find the probability of obtaining 2 red balls, A, B, 2 white balls or 2 black balls, C, 1 black ball and 1 red ball in any other. So total balls is 10 with replacement. So the total balls stays 10 throughout our experiment. Now events are independent because we can replace it, right? So probability of 2 red balls is going to be red on the first choice and then red on the second choice, right? So we have 3 out of 10 and 3 out of 10 is equal to 9 out of 100. Now probability of 2 white balls or 2 black balls. So probability that white balls or 2 black balls, 2 white balls or 2 black balls. So we find the probability that occurrence for 2 white balls, right? That means white and white. Remember, it's replacement and it's independent. All right, so we get for the 2 white balls. We do the same thing for the 2 black balls as well. And then we multiply the resultant to get 29/100. Now probability of 1 black and 1 red in any order. So probability of black and red, 2 out of 10 times 3 out of 10. And probability of red and black. So any order. It can be red first or it can be black first. All right. So we can have multiplying that together. We have 6/100 and another 6/100. And that gives us 12/100. Yeah, we can cancel 12/100 out. And that gives us 3 out of 25. Question 5. The probability that 2 boys pass an exam are 2 out of 3 and 5 out of 8. Find the probability that I, the boy, passed the exam. Only one of the boys passed the exam. So given these outcomes and probabilities, probability that both boys pass the exam, so we are assuming the probability are independent because it wasn't stated. And then we have that it gets 10 out of 24. I suppose you understand what we are really doing. So 10 out of 24 cancels down to become 5 out of 12. The probability that only one of the boy passes the exam. If one pass, one will fail in that regard. So A passes and B fails, or A passes and B passes. A fails and B passes. So we find the complement of each. And after that, we use our formula to work our workout. And then we have our final answers to be 11/24 in that sense. All right.